Now, if I have fourth line, the maximum number of spaces that I'm looking for. En fazla bölge sayısı. Here, fourth one. Then we have 1, 2, 3, 4, 5, 6, 7, 8 unbound ones. 8 unbound ones, yes, 8. And you have 1, 2, 3, 3 bound ones. A total of 11. If I have a fifth one, with the fifth one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 unbound ones. As you see here, they go 2 by 2. And here you have 1, 2, 3, 4, 5, 6. 6 of them here, a total of 16. It looks like it increases by 2 here, 3 here, 4 here, 5 here. And here we have 0, 1, 2, 3. Probably you have 4 more, probably, not sure. Okay, so how do you compute with n? With n, what are these numbers? An, bn, and cn. Can we find a formula for this? This was the question. Any answers? You should have given this as a homework anyway. Well, I don't know the answer offhand. Let us see. Now, you don't want 3 lines to intersect, because then the number of areas is not maximal. See, you move this a little bit like this, so you have a new area here. So each new line, suppose I have here an. I have n lines and an areas. Now I have a new line. I'm going to take a new line. This new line, in order to maximize the number of areas, must intersect each line once. Like here. Let me do this in red. Is this red? It's not really red. Don't we have a red? I have a red here. This new line intersects this. This separates this part, this area, into 2. It adds 1 more, plus 1. And when it intersects another one, it separates this area into 2 parts, plus 1 again. Each time it intersects a new line, it separates the previous area into 2. You have 1 more, and 1 more here, 1 more here. Each time it intersects a line, you have 1 more area. So before I had n lines, here I had n lines. Now I'm looking for an plus 1. An plus 1 is equal to an, the number of previous areas, all these, plus number of intersections, plus n, and plus 1 more for the infinite, this part. This was before infinite, right? So when the line starts from here, it Every time it intersects a line, it adds one more area. It intersects her kesişte, her yeni doğruyu kesişte ne artı bir şey doğruyu alıyorum ben. N plus first line. Each time it intersects a new line, it adds a new region to it. There's 1, 2, 3, 4, 5. So you have 5 regions, 1, 2, 3, 4, 5, and plus a new one. So this is n plus 1. This is the formula. This is the formula. Let us see. Okay, and what about for Bn? For Bn, for bound ones, for unbound ones. You get a new unbound one here. A new one. And you get a new one here. You get 2 more. So Cn plus 1 is equal to Cn plus 2. Yeah, 2 more each time. So as you can see here, 2 more, 2 more, 2 more. Okay, so this is going to be, so this is twice this number each time. 5 and 10, 4 and 8, 3 and 6, 2 and 4. With one you have 2 unbounded. So each time you add 2 more, 2 more, 2 more, you get double 2n. The Cn is 2n. This is the formula for this. What's the formula for An? What do? I start with A1. So I'm looking for An. Okay, An. I start with An, with A1, which is 2. Then I add 2 more, plus 2. Then I add 3 more. You can see from this formula here. Now, then 4 more. And then 5 more. This is plus 5. If you have 5 here, you have plus 5 here. So if you have n here, if you go up to, so you have to find this sum. This is 1 plus, right? This is 1 plus 1, 1 plus 1 plus 2 plus 3, and so on. The sum of consecutive numbers. Ardışık sayıların toplamı. Birden neye kadar? Bunun formülünü herkes bilir. Bunun formülünü gösterelim. Bu sayıya S diyelim. Sn diyelim bu sayıya. Sn eşittir. This is Gauss. According to the story, Gauss, when he was 6 years old, the teacher had something to do, so he or she gave them an exam, a question, to calculate the sum of the numbers from 1 to 100. 1 plus 2 plus 3 plus 4 plus 5. Gauss is only 6 years old or 7 years old. He's the first year in elementary school. İlkokulda 1. sınıfta da. And then he said, 5050. He found the correct answer. Of course, the teacher was amazed. She said, how did you do it? He said, well, it's easy. Okay, so I want to, let's call this S. S is S100. This is 1 plus 2 plus 3 plus, keep going, 98 plus 99 plus 100. Write S again, but now with the reverse order. Sıralamayı ters çevir. 100'den başla. Start from 100. 100 plus 99 plus 98 and so on. Plus 3 plus 2 plus 1. And now add these equalities. Here we get 2 times S100. Here we get 100 plus 1, 101. Here we get 99 plus 2, 101. Again, 101. All the way to the end is 101. You're adding 101s. How many times? Well, how many numbers do you have here? Here we have 100 numbers. So here we have 100 many 101s. So 2 times S100 is equal to 100 times 101, and S100 is equal to 100 times 101 divided by 2. So this is 50 times 101. This is 505, and then you add a 0. If you do it with n, Sn, with general number, you get 1 plus 2 plus 3, and so on, plus n minus 2, plus n minus 1, plus n. You write again Sn, but now from the reverse order, n plus n minus 1, plus n minus 2, plus 3, plus 2, plus 1. And you add them, like in here. You get 2 Sn here. Here we get n plus 1s. N plus 1. This sum is n plus 1. Here we get n plus 1 again. Here n plus 1 again. Here n plus 1 again. All the way to the end, we're adding n plus 1s. How many of them do we have? Well, the number of numbers that you have here. We have n many numbers. So here we have n many n plus 1s. So 2Sn is equal to n times n plus 1. So Sn is equal to n times n plus 1 over 2. For example, if you add numbers from 1 to 4, 1, 2, 3, 4. So n is 4 here. You have 4 times 5. 4 times 5 divided by 2, which is 10. As you know, this is 10. Okay. Numbers from 1 to 100. N is 100 here. 100 times 101 divided by 2. It's 50 times 101. It's 5050. So this is equal to, I have 1 here plus n times n plus 1 over 2. Bring to the same denominator, 2 here, n squared plus n plus 2. Let us see. If n is equal to 0, yes, if n is equal to 0, if n is equal to 1, you get 1 plus 1 plus 2, 4. 4 divided by 2 is 2. If n is 2, 2 squared is 4, plus 6 plus 8 divided by 2, 4. If n is 3, 9, plus 3, 12, 14 divided by 2, 7. If n is 5, 25, 30, 32 divided by 2, 16. Okay. This was the first question. The second question was with the circles. With the circles. In how many areas do you separate the plane with circles? With 1, we have 2. Outside and outside. 1, 2. With 2, we have 4. Outside 1, 2, 3, 4. It looks like they're equal now. They're all equal. With 3, let's see. 1, 2, 3, 4, 5, 6, 7, and 1 outside 8. It goes like 2, 4, 8. Now with 4, let us see if it's going to be 16. The maximum number of areas, of course. Let us see. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and one outside 14. Yeah. With 5, it's much more complicated. I know the answer, but I will let you guess the answer. I will let you find the answer. What is this? Okay? So I will repeat the same homework. And I will ask one more homework. I guess I should ask one more homework. Here we found that 1 plus 2 plus 3, so on up to n, is equal to n times n plus 1 over 2. If you are curious enough, you should ask yourself, what is 1 square plus 2 square plus 3? The sum of the consecutive squares, starting from 1. What are they? A formula for this. And for the cubes. Can you find the formula? Well, you can find it on the internet, of course. It's a famous problem. But try to prove it. Or maybe play with it. It's called, I help you, Basel's problem. Basel is a city in Switzerland. And then 4th powers, of course, 5th powers. So, okay, so as a homework for next time, write something, write an essay on powers. It could be historical, it could be philosophical, it could be your own experience or something. Write something, but with care, please, with punctuation marks, commas, periods, exclamation marks, whatever, question marks, and paragraphs. You should have some taste, you know, some nice writing, nice literature. Bir şeyler yazın. Yani iyi yazın ama. Yani üstünde durun. Biraz çalışın biraz. Yani masa başında çalışın biraz. You have to work a little bit. I must say that I'm not very happy with this course. I expected something much better. Are there any questions? No questions. Okay. Oh, yes, Mohammed, come on. Thank you. Thank you for these nice words. Amazing approach. Yes, yes, it's beautiful. It's all pretty. It's all pretty. You see, if it were not pretty, it wouldn't exist for 4,000 years or 10,000 years even. Math is pretty. It can only be pretty. Anything which lasts for thousands of years can only be pretty. Nothing ugly remains in the world. Carpentry is a work of thousands of years. They are pretty. They can only be pretty. Okay, so I have two homeworks. First of all, with circles, when you do the same problem with the circles, with end circles, this is called the end. And this number was n squared plus n plus 2 divided by 2. What is dn? Can you find the formula for dn? Can you guess this number here, for example? And the second question was, here I found the sum of the first n numbers. I found the form, this is here it is. You prove this. What can you say about this sum of the squares? Can you find a formula like this for the sum of squares, for the sum of the cubes, for the sum of the fourth powers? Well, this is not too easy. It's not too easy. This was easy. I did this here. This was easy. Well, I can prove this in some other way. Let me do it. So I'm going to do something like this. Okay, so here I have 1 square, here I have 2, 3, 4, and so on. Here I have n. Okay, so number of squares is 1 plus 2 plus 3 up to n. Okay, now make a copy and paste of this and reverse it. Okay, so let's call this Sn. This is Sn. Sn is this. I have another Sn here, so I have two Sns. When you put this together, put this together, make it touch here, you get a rectangle with n here, n pieces here, 1, 2, 3, up to n, and here you will have n plus 1, n times n plus 1, small squares. So Sn is equal to n times n plus 1 over 2. You see, math is as beautiful as painting, dancing, ballet, music, sculpture. You know? So these tasks are in the world for thousands of years. They wouldn't remain if they were ugly. They cannot be ugly, or else they will disappear. Çirkin olan bir şey kalmaz yeryüzünde, gider yok olur. Okay. So see you next week. Bunların bir fotoğrafını çekiver.
Aldım hocam.
Tamam.